episode of Rustacean Station. I'm your host, Alan Wyma. Today I'm with Greg Johnston, the creator of Leptos. Hello, Greg. How are you?
Hey, great. Thanks for having me.
So we're just having a good chat, trying to think about how the heck we can even start this episode, to be honest. I'm drawing a little bit of a blank, maybe because it's a Friday night for me. Why don't we start a little bit on your background, right? Because your background's quite interesting. Maybe you can kind of quickly introduce your background.
Yeah, definitely. So I'm actually not a professional software engineer by any means. I'm a hobbyist. I've been a hobbyist for probably 20 years since I was a kid, but I'm actually my day job as a minister in the Episcopal Church, which is kind of progressive Christian denomination in the US. But I've always sort of been doing programming work along the side, just of whatever else I'm doing in my life. Like I said, literally since I was in fourth grade and started learning Java, animating a little dog walking around in an applet, right? But a lot of I kind of got back into the programming work during the pandemic. I had created a couple of online tools for kind of spirituality and religious stuff. And it turned out those became really, really popular and useful for people in, spring of 2020 when everything was shut down and was online, and kind of got a lot of popularity and use out of some of the tools I'd created. And out of that, I actually had a couple of other organizations reach out to me to do some freelance work. And I was moving to a new job at the time, a new church job, which happened to be part-time. So I was able to sort of combine this part-time work in the actual church with some freelance web development and stuff, and kind of built things up from there. So it's been a pretty interesting thing for me, coming in without really formal training in computer science or anything, but just kind of long-term, I guess, experience and perspective from the hobbyist end rather than the professional, of seeing how things have unfolded over a few decades, and, having built stuff with Django and Python and, the whole kind of span. And we're almost coming back to some of the same patterns that we were using when I was messing with stuff in high school, which is kind of interesting. So that's kind of how I got here in web development.
Okay, so you actually did some Python before. Like, what other kind of programming languages have you actually worked with?
Yeah. Oh, man. So
Besides Python, right? So what else?
yeah. So let's see. I started with a little bit of Java, but that was when I was a really little kid. I actually got into Lisp for a while. So one of the first things that I really made and used for myself was a little silly. It was before we kind of had the Web 2.0 model, and we're thinking of, okay, we're going to store user-generated data in a database somewhere on the server. So I actually made this scheme app, like the Lisp dialect scheme, that had a user interface and stored your data. I was a cross-country runner, and so it was a running log application that you could use to track, like, okay, I ran 3 miles, it took me 20 minutes. And it would do things like track how many miles you'd put on your shoes, so you knew when you needed to replace them and things like that. And it stored all of your data as serialized S expressions in a text file on a thumb drive. And my idea was, like, you get this thumb drive and then you can go around, and, like, I went up to running camp for a week in the summer, and you can bring your thumb drive with you and plug it into a computer, which was, thinking back on it now, sounds so dumb, right? Because why would you not just have a website where you did this? But at the time, it was like trying to think through, okay, how can you actually make a piece of portable software that has personal data on it? And I actually rewrote the same thing later in Python using Django. And, it was just using it for my own personal thing, right? It was a fun personal project. But that was, a particular pattern. I think Django is really powerful and a really great tool for certain kinds of applications where you have, like, it gives you this really structured CMS that's based on your database models. It's kind of like Rails, Django. They have this very opinionated framework for certain kinds of applications that works really well. And then I actually for a little while, I was experimenting in Python with some kind of, like, social media account. What would you even call it? Aggregator. So you could put in, like, your Twitter account, your Facebook account, even email. And this was back in the days before they really had their algorithms to serve you very particular things. And you just got, like, a raw feed of what your friends were posting. And they had these APIs that you could just pull that in, and it would all be in one place. And that's the kind of thing, of course, that, like, Python and Django are not great for. That's, like, really front-end heavy work, right? That's basically an Ajax type app. But so I was just messing around with this stuff for my own, personal things over the years, and, went in different directions professionally, whatever, but was always, kind of building these tools. So I feel like I've experienced a bunch of different ways of looking at programming and different kind of aspects of things, and none of them in this, again, like, professional intensive way. But yeah, I mean, it made it so much easier for me to learn Rust that I'd actually spent some time in assembly language when I was in high school, and doing things like trying to, fit a bootloader into the first 512 bytes of a floppy disk, and, like, rebooting a laptop with the floppy disk, and, trying to create your own little operating system. So just having that kind of breadth of experience has been super useful for me between the system side and the more application side with Rust in particular.
Now, I'm kind of curious because you're extremely passionate about programming and you're doing it kind of on the side,
Yeah.
but you're also a minister full time, right? Or you really kind of devote yourself to church. Do you ever get torn between like, maybe I should keep going in this route, or you're happy where you are? You kind of like this nice split you have?
Oh, totally. Yeah, no, totally. I actually had a great mentor in high school when I was really seriously considering like, do I just want to go, CS? And she sort of said to me, you could do that. I also really see in you so many like what we would call soft skills, right? Just like the people stuff and the, working with people. And I do really enjoy that and find a lot of meaning in that. And of course you can do that in the tech world, right? There's working with people all the time. But for me, what's been really, I think where I've kind of found my niche that's been productive for other people rather than just for me is in the overlap between a really deep domain knowledge, like the religious world that I'm coming from, with the tech abilities. So there are a lot of, when I do sort of freelance work for clients, most of that has to do with, it's mostly for church related things. And it really has to do with things where if they just went out and hired a random iOS app developer or something, and they were trying to describe the problem that they had and what they needed to be doing, they would just not be speaking the same language at all. And for me, what's really been fruitful has been like the overlap where it's, programming work, but that I have the religious language to be talking to people and kind of bridging that. So at this point, I'm basically, 60% church work, like in a church, and 40% the tech work. So it's kind of a good balance for me. But yeah, it definitely is. You lose, I do a lot of nights and weekends for my own projects and stuff, like I think a lot of us do. So it's a little hard to keep that in balance. But I think I would miss either of them. If I went to 100% in either field, I would definitely miss the other one pretty deeply.
Okay, that's pretty interesting. But that's a pretty good market, I think, that you can do this kind of thing. There's not many people, I think, that are truly where you are. I mean, there's many religious people, but not many religious people as minister, maybe not even as deep. There's a couple of theologians, right? I think that we talked about Chris Krycho. I think he's also a big
Hmm.
theologian, right?
Hmm.
So he would be kind of in a similar domain, although he's working for LinkedIn, so he's not in
Right,
that
right.
market. So you're kind of got the market cornered, right?
Right.
Oh, that's awesome. It could be some. I don't know how good is the religion based software, because I mean there must be a lot of things that churches need, and there's must be vendors out there, right? You ever thought about making a company doing something like that?
Yeah. It's definitely a possibility. There are a bunch of them. A lot of things are in the kind of database realm, like what in the business world would be called like, Salesforce type things, right? Like client relationship management, except it's not, a business relationship. It's with people in the congregation, but like address databases and contacting people and, organizing volunteers and stuff. And that actually there's a lot in, and that's pretty well covered. But yeah, mine has been kind of a different area that's more around like daily prayer applications and things that are serving people content on a day-to-day basis. So this was, I think I wrote this little joke about my week. This Wednesday morning, I gave myself a classic JavaScript experience, right? Which was, I'm serving all this daily stuff, and there are different, maybe there's some readings, maybe there's some prayers you're going to say on this day. And I just had this classic experience where somebody said, "Oh, I'm not sure this is quite the right thing for that day. Could you check that?" And I said, "Yeah, sure." And I went up and, okay, I see the bug that's happening here. And then I check the next day and the entire page crashes. And it's just a loading ... And I open DevTools, right? And it's like whatever the error message is, I'm trying to access, dot first reading on undefined. And it's like, oh no, I could have sworn to you that function would never return undefined, right? And even with TypeScript in JavaScript, you have to be so careful. Like I almost feel now like they have this little optional chaining question mark on everything. And it's like, I almost feel like I have to put it on every single field access now because it's this JavaScript experience of you're writing in a language that isn't typed really. And even when you have typing tools, they're not perfect, or they're, the way TypeScript defines array access is you access an index on an array and it gives you the type T. It's not T or undefined, right? So like it doesn't even protect you from trying to access something like that. And so of course I've got a bug in production and I'm scrambling to fix it, whatever. I was just thinking to myself, man, if this were Rust, I literally could not write that program, right? Like that would be an option T, and I would have to handle that some way. And if I were, I would know if I were writing unwrap there, and that would be my fault. But in JavaScript, it's like a hidden unwrap everywhere. And so that was just my like, man, I wish I were writing this thing in Rust. And that's a lot of how I ended up, creating a framework, right? Because it was that feeling of I make web applications. I really want to be able to write them in Rust. And I'm not super happy with the existing options for doing that. So what can I do?
Yeah, that's interesting because I was just thinking to myself, well, you can do something similar if you have unwrap, right? This will never be an error, let me just unwrap it, or I forgot which one is the right. Is it unwrap for option? I think it is.
Hmm.
Okay. Yeah. So then you'd still have the error, but like you said, then you would just accept it and just handle the possible error, right?
Yeah, and what it is, I mean, I think what it is in JavaScript is that there are implicit unwraps everywhere, and you don't, it's really hard to distinguish between, okay, this function is returning an option t, and this function is returning a t. So I would have sworn to you that that function would never return undefined, and I was wrong. That was my own fault, right? Like I wrote the function, but it's just really hard to police yourself about that stuff. Whereas in Rust, it's just, if you're unwrapping something that you're unwrapping it, and you can't do it accidentally, right? Like you can do it and it would be a bad practice, but that's kind of on you at that point. In JavaScript, even if it's also on you, it's a different sense of it.
Have you ever, I mean, you're a Lisp person. I'm guessing you're kind of in a little bit into functional programming, right?
Yeah, yeah.
So have you ever taken a look at Elm before? Have you heard of Elm?
Totally. Yeah. And Elm is really fascinating. And Elm, for anyone who's listening and doesn't know, I think in a big way, Elm has kind of set the agenda for a lot of JavaScript front end frameworks and absolutely for a lot of Rust web front end frameworks. Like the Elm model, even though Elm is a very different language from Rust, it's garbage collected. It actually compiles to JavaScript and runs in the browser, so you don't have all the memory safety stuff. But they have this very strong immutability as a functional language, and it turns out that Elm patterns make for really nice Rust APIs because Elm has like a model, a view, and an update function. And the model in Rust is just like a struct that defines the data, the state of your application. The view in Rust would be a function that takes an immutable reference to your model and returns just an owned structure of the UI. And the update in the Rust equivalents takes a mutable reference to your model and like a message type, which is basically an enumerated type for all the different actions that could happen. And then it's a finite state machine. So it just updates your model and then re-renders the view, it makes for really beautiful Rust code because you're working just with normal Rust mutability rules and everything. And this is the model, as far as I understand it, of you in its sort of older form. I guess their functional components are more like modern React with hooks and stuff. But this is the model that you uses. This is the model that Sauron uses, which is another Rust framework that's pretty cool. And it makes for really great Rust code. The problem is it's hiding all the overhead from you. So you think you're writing this really beautiful Rust code, and then it has this really big runtime cost because that's not how browsers actually work. So it has to do all of the reconciliation on its side, which is kind of the big difference between you or that kind of Elm approach and something like Leptos. It's the same as the difference between something like React in JavaScript and something like Solid in JavaScript. They're just different ways of describing how the state of your application should change and then how that gets translated into the UI changing.
Yeah. What I'm thinking about for Elm is like there's no way that you can do an unwrap. You actually have to always handle the error, which is it's both annoying and good, right? You got the same thing in Rust. But I
Yeah,
think Elm is more like you have to do this no matter what, rather than
right,
like Rust you can choose to opt out kind of.
right. I mean, Elm's big claim is basically if you write a program in Elm, you will have zero runtime errors. Like the language makes it almost impossible. I think they'll admit that once they wrote one at what's it called, No Red Ink or something is the company that Evan was working at for a while, the creator of Elm. But I think they claim, okay, we had runtime error once and we were using the API wrong and it was sort of our fault. But basically the idea is, yeah, they don't let you do the sorts of things that would panic in Rust because their sense of safety, right, again, it's compiling to JavaScript. So memory safety isn't really a concern and it's in a browser, which is sandboxed. Their idea of safety is you don't throw any exceptions, right? Like there are no errors in your console and in the browser. You just have to handle all those eventualities.
Yeah, I think the error was actually like there's a like debug or something that you can use to manually crash the program and see what's going on at that time. So I believe that was the thing that they had. It's been a while, but I know what you're talking about. Is it Richard Feldman or is that
Yeah,
the
yeah,
name of
yeah.
the famous guy? Isn't it the name of the famous guy who had an interesting life, or is that
Oh, I don't
the
know.
guy from it's Richard something? I'm pretty sure it's Richard Feldman or something like that.
I think it is.
Yeah, but there's another guy named I think Richard Feldman with the same name. Oh, sorry, I think about Richard Feynman.
Oh, the
Sorry.
physicist. Yeah, yeah, yeah.
Yeah, because the name is so similar. No, no.
Yeah,
So
totally.
Richard
No, I
Feldman,
I, I
yeah,
thought that too.
he's the one. Yeah, he's the one.
He has that great talk to making impossible states impossible, which is all about how to using algebraic data types, using your structs, using your enums to make it so that you can't represent a state that your application can't actually be in. So like rather than just having a bunch of these Booleans of loading and error and success, there are lots of combinations of, you can't have error and success at the same time. So why do you have two Booleans? It's great. Just they've done a lot of great work on that stuff of how do you think about and define and model the state of an application.
Yeah, I guess the only thing that's maybe might turn people off about Elm is like I just took a look at their website while you were talking, and they're at 119.1, and they basically said that they don't plan to change anything, which I don't know if it's good or bad. You might see that as bad, right?
Yeah, I mean, the Elm community has, and the sort of way that the languages run raise questions for a lot of people about kind of what the path is going forward. Just for example, they've made the decision, the kind of principled decision that they don't want to just give you access to kind of web APIs directly that you can access from JavaScript because they want to design their own APIs and maybe we'll eventually have native support. You might not have the browser, but they've also been traditionally kind of slow to produce that stuff. So there are more and more things over time that you just can't do. And, there's drama within that community that we don't need to get into, I think. And I haven't really done a lot of Elm programming, to be perfectly honest. I just don't like the kind of Haskell syntax. I don't like looking at that. I prefer my curly braces and my parentheses and things. So I don't know if I would ever really use it seriously just for that reason. Although I'm sure if I got into it, I would get into it. But yeah, I mean, there's a reason I don't do Lisp anymore. It's syntax actually does matter, I think, for the kind of developer experience when you're working on stuff.
One of the coolest things about Elm, and I don't know if you remember this, but they do have like the what is it called, the time traveler or something like that, where you can get the whole history of what happened. Have you seen this before?
Oh, that's interesting. Is that like a feature that you would use in your application, or is that like a dev tools thing that you can see it?
It's kind of both.
Yeah.
So I've learned Elm a long time ago, and what they had that was super interesting to me was so as you're clicking, you have a state, right? And you have messages, and these will actually get recorded, and then you can actually ask people to export, and then you can import that data onto your app, and then you can replay it, and then you can start to figure out what happened and why the application quote unquote broke,
Yeah.
which is super interesting.
Yeah, and that's great for a lot of reasons, right? It's great for like a customer support thing and a debugging thing. And it's the sort of thing that you can do something similar for, I don't know if they have this as a feature, but with something like Redux, which is basically the model of a state machine like that driving your whole application in JavaScript. It's not anything, I think, where you have that kind of global state and this message based architecture. That makes sense. You can store those messages and replay the whole thing. And because it is really deterministic, you don't even actually need to keep the states. You just need the initial state, and then the chain of messages will get you to the exact same place.
Yeah, because you have like reductions happening, right?
Yeah, exactly.
But going back to what you created, so you created this library called Leptos.
Hmm.
I took a look at it, but to be honest, it's hard for me to kind of understand because I think like a lot of different languages, or sorry, a lot of different front end frameworks, they have their own style because like you're trying to make a UI with HTML within Rust code. So you have your own DSL, and it's like, okay, what does this actually mean?
Yeah, yeah.
Maybe you can kind of explain what it is and what were the inspirations of it.
Yeah, definitely. So, I mean, the inspiration, if for anyone who's familiar with kind of JavaScript front end world, for about the last 4 or 5 years, there's been a library that's called Solid.js that's basically the fastest in terms of just rendering speed on benchmarks. So, the JS framework benchmark, which has been around for a long time and is really just measuring your ability to render a bunch of stuff in the browser really quickly. And it uses this particular architecture that has just been the fastest, right, relative to any other framework for 4 or 5 years at this point. And so that's sort of been the main inspiration for me, and it's where I've taken a lot of the architecture for Leptos. The reason I started developing it, right, was I think there's this very common conversation you'll see it like on Reddit or Twitter or whatever. So somebody starts with, I love Rust. Like if you're listening to this podcast, you may well love Rust too. I don't need to give you all the reasons. I was talking about my own, JavaScript foot guns, whatever. A lot of people just say, I would rather be writing this thing in Rust. I want to do that for, the front end. And I know that I can compile stuff to WebAssembly. And then there are a couple of different like takes that people have, right? And one is this really naive take that's, man, WebAssembly is the future, right? People are just going to be shipping binaries down. You're going to be rendering everything in a canvas. It's going to be like native GUI in the browser. And that's in my opinion, a super naive take because it turns out that building a native, I mean, you see this in the Rust world, right? Building a native renderer and GUI toolkit is really hard, and things like accessibility and things that are just baked into the browser are really hard. And then you have to ship all that down to the client, so it loads really slowly. So that's not really realistic. But you'll hear a more realistic one, which is, the interop between WASM, between WebAssembly, and between the DOM is just too slow to build a user interface, because the way browsers are right now, WebAssembly isn't allowed to call DOM methods directly. So you can't create elements. You can't set attributes on elements. You can't put text on the page without calling out through JavaScript. And then JavaScript calls the DOM and then returns the value back to WebAssembly. So it just adds this constant overhead for any UI work you want to do with WebAssembly. So people say, yeah, WebAssembly is for really math intensive tasks. You offload it there. And there's some value to that. So people will say things like, okay, well, so if you want to write the UI, do your backend in Rust and then use something like, Svelte, React, Angular, Vue, Solid, one of these JavaScript front-end frameworks for your UI. And it turns out that that's not really true. If you look at these benchmarks, it is true that for any given front-end framework architecture, the Rust version is going to be slower than the JavaScript version because of the overhead of that interrupt. But the differences between those different architectures are bigger than the differences between JavaScript and WebAssembly. So in other words, the reason that Leptos has gotten some visibility or whatever recently is just that, the JS Framework Benchmark released its, version that had Leptos in it, and it's the fastest Rust front-end framework by a pretty good margin. And it's faster than the JavaScript ones that people recommend to you. So it's significantly faster than Svelte. It's among the fastest front-end frameworks overall, and it's a little bit slower than Solid because they have the same architecture and you have that little bit of WebAssembly overhead. So it's really possible to create very performant, very fast front-end UI in Rust. It's just a matter of the architecture of the framework. And so I kind of set out, I wanted to prove that. And it's the difference in the architectures that really makes a big difference. So, you look at something like Vue, and they have two versions in that framework. The Vue hooks one is a lot slower. I don't really know why, but the kind of classic Vue one, it's faster than React, which is another virtual DOM library. It's slower than Preact, which is, another virtual DOM library. It's slower than Vue. So it's kind of, it's reasonably slower than the JavaScript equivalents. You look at something like Sycamore, which is very similar to Leptos. Sycamore is faster than something like Svelte, faster than Vue, faster than Preact, faster than React, faster than Angular. Sycamore is, a good deal slower than something like Solid. And Leptos kind of closed some of that gap. But the big difference between libraries like Vue or Dioxys in Rust and libraries like Leptos or Sycamore is the difference between this virtual architecture and this fine-grained reactive one. So maybe it makes sense to just kind of walk through what those things are actually doing when you're rendering a component. Say you have a really simple counter, which is a button that says, click me. And every time you click it, there's a little number next to it that says, the value. So you, or in Leptos, you would represent that as a component, and it would have some state that's defined. So in Leptos, you'd create a signal, which is a reactive value. So a value that when it changes can notify something else that it's changed. And in Vue with hooks, you would use the use state or something. And then you're rendering it, right? And a component in a virtual DOM model like React, Vue, gives you this virtual DOM representation. So it's literally it's in Rust, it would be a struct, and it has an element name that's the string of the HTML element tag. And then it has attributes, that's a vector of an attribute name and a value. And then it has children, that's a vector of more elements. And you can create this whole tree of these virtual DOM nodes. So the view says, okay, we've got a button. And then that button, say, has a class that's, button primary, and then has a child that's click me. And then we've got another element that's maybe a P, a paragraph tag, that has the value. And every time the state changes, you or Dioxys is going to re-render that component. So then the state change triggers the component to re-render, which recreates that virtual DOM tree. So it says, okay, the state has changed. We need to re-render. And it generates the new tree. And then it compares the two of them, and it diffs them, and then it patches the DOM to match the new one. So it literally takes your two trees and it says, okay, I have a button. Do you have a button? It says yes. I have a class attribute. Do you have a class attribute? Yes. Mine says button primary. Does yours say button primary? Yes. I have a text node. It says click me. I have a text node. It says click me. Okay, now I've got a paragraph. I have a paragraph too. I have a value. The value is 0. I have a value and the value is 1. So then it tells the browser to change that text node to 1, right? And then you click it again and it goes through that whole process again and it diffs all those nodes and it creates those things. And if you're listening, right, like there are allocations in there, right? It has to allocate for those vectors to put the children into, to put the attributes into. Leptos or Sycamore does something very different. And I'll actually just do the Leptos example because this is where it is different from Sycamore. The view macro, right? This is a compiled language. We have to compile this ahead of time. So we know when we're looking at it, when you put an HTML button, class equals button primary, that is never, ever, ever going to change. The way you've written that code, that literally cannot change because it's a literal, right? So we say, okay, great. And button, class equals button primary, click me, close button, open paragraph tag. All of that is static. So we put it in an HTML string. And then, it's a proc macro, right? You can be relatively smart. So it says, oh, now I see you've inserted this is why we have those closures in the Leptos examples. You've put a block here and some curly braces. And oh, there's a closure here. So that's the kind of thing. It's a function, right? We can call it a bunch of times and it gives us a different value every time we call it, possibly. So when I see a closure, I'm going to create an effect that gets the value of this signal. And the way fine-grained reactivity works, you have signals and you have effects. And a signal is a value that can change, and an effect runs whenever there's a reactive value read inside it that changes. So the effect literally calls the value of that signal. When you call the value of the signal, it says, hey, is there an effect that I'm inside? It says, oh yeah, okay, so subscribe that thing to me. So it sets that initial value. And then when you click the button, it updates that signal +1. And the signal says, oh, hey, there's an effect subscribed to me. Tell that effect to rerun, and the effect reruns and updates the text node. And then you click it again, and the effect runs and updates the text node. And then you click it again, and the effect runs and updates the text node. And you're missing that entire process of rebuilding the whole virtual DOM, right? Creating that button structure, those attributes, allocating for that vector, creating the children, allocating for the child, diffing that against the old VDOM. That entire runtime process is gone because at compile time that certain things never can change. And you also know at compile time, you have these targeted updates to the DOM because you know exactly which text node is going to change when you update that signal. So you do not need to do any diffing on the component as a whole. So in a sense, components in a virtual DOM model like you have an actual runtime significance because you want to make your components relatively smaller because the whole component is going to rerun when any of its state changes. So a lot of kind of performance optimization in virtual DOM libraries has to do with getting your components to be the right size so they're not re-rendering as often. Leptos doesn't care at all. A component is just a function. It doesn't rerun. It just creates this template and this reactive system, and you can organize things however you want. But so it's really that is the difference, and that's the performance difference between these fine-grained libraries, Leptos, Dominator, Sycamore, and the kind of Dioxys, virtual DOM libraries in Rust.
Very interesting. I mean, some of this reminds me of how Phoenix Live View works. Have you taken a look at something like that, these kind of back-end frameworks?
Yep.
They send you over the wire, at least Live View sends you over the wire, static content, dynamic content, and they use MorphDOM to zip it together. And then, like you said, already what's static, what's dynamic. It'll just send you just the dynamic part, only that little part that's changed over the wire. But this one is got some similarities, but obviously there's some differences, right?
Yeah, and this is just the front end part of the story, right? So you
Exactly.
don't have that client server part of it. But yeah, I mean, there's just a lot of unnecessary work. So people will ask questions sometimes like, well, why can't I just, when I write a component in I can just use normal Rust borrowing rules and I can just access this value. And why do I have to call this getter in Leptos to get the value out? And it's, because like I said, when a virtual DOM library like is giving you that really smooth Rust interface, the way that they're doing that is by creating this runtime overhead that handles all the nasty parts for you. And that's just a different approach. Like there are times when that's a better developer experience, but there are you can see the performance implications of it. And I'll say, we actually have the same exact situation on the server side. So in terms of server side rendering HTML, Leptos, at least in the benchmarks that I've done, Leptos performs a lot more like a templating library like Terra does in Rust than when you try to server-side render U, which they haven't released yet, but it's in their master branch on Git, and they're releasing it soon. Because, again, the Leptos, we just have a different code gen in this proc macro for the view, and it knows, oh yeah, you're just generating HTML strings and serving them. And then it's just a question of string concatenation, inserting the dynamic values into those empty slots in that string. It's literally like pushing things onto a string, right? And then returning the string. And you don't have to do all this work. I think when U is rendering in server-side rendering, it again is creating that virtual DOM, and then it walks that and pushes things into a string, which again is like pretty fast. I mean, these differences, they're both really fast. It's a relative difference, right? So, and I think this is a lot of the opening for Rust in the web going forward. JavaScript frameworks are actually moving back in the direction of trying to do more work on the server, back in that Phoenix Live View model in a lot of ways with like React server components and things, back to trying to render more on the server, because shipping down a lot of JavaScript is where a lot of the slowness in the internet comes from, honestly. But there's real performance benefit in a Rust server rendering HTML over, a Node.js server rendering HTML. There are real performance improvements when you're running something in Rust on the server side relative to this full stack JavaScript. And people want to build full stack applications, right? The server and the client using the same language, because there are a lot of benefits to that. You can share types across the client and the server. It makes your interaction with APIs a lot easier. But the result of that on the web has been to push, we only had JavaScript on the front end, and that has pushed JavaScript into the server where there are more performant languages we could be using. And now it's like, we're getting to a point where you can reasonably use Rust on the front end, and we know that Rust is really good on the server side. So my goal is to free people who want to be able to write their whole application in Rust to not have to worry about, but is the client side rendering in Rust too slow? Because the answer is no. If you're using the right architecture, it can be very fast.
Yeah, if I'm looking at the example you have for your first example, obviously it looks pretty similar, but there is a difference where you have the on colon click, and then you're not missing like the double quotes around the function call name. So there's a little bit of syntax you have to kind of pick up on. It's close, but not 100%, right? So
Yeah. In terms of like
kinda,
the curly braces everywhere. Yeah. And you can use those. It's actually funny. I use a crate called syn rsx. So it uses the syn crate to, have a macro that builds a kind of tree from RSX like that, right? JSX is JS XML. RSX is doing it in Rust. And it's kind of funny, just the way that the parsing works. You can wrap things in quotes. Clippy will complain about you about unnecessary curly braces if you do it, because the way that the macro works, it's already wrapping stuff in braces, because it's visually a little more unclear for people sometimes, I think. But you don't actually need, right? Like you could inline in that example, if it's the one that's in the README, those clear decrement increment closures, those could all be inline in with that on click. And when Rust is parsing that, it doesn't need braces around a move closure, because it sees, okay, I've got move, I've got any closure, right? I've got move, I've got the arguments to the closure and the template to put them in. But it's not actually necessary from like a parsing perspective. But it doesn't really make a difference either way.
okay, so this is actually using, what do you call it, syn rs, is that right?
Yes, syn rsx.
Yeah, so which is already something I've never looked too much at the front end with Rust, so it's already a popular crate, I'm guessing, because it looks very, you're using something's already people using, right?
It should be a lot more popular, really. It's the
Yeah.
sort of thing that you wouldn't know about unless you were developing a framework. So it's never going to be popular in that sense, but it's a really good kind of backbone library. I mean, saved me a huge amount of work. Writing proc macros is hard, and especially doing code gen with like I'm doing, it's just hard to see what you're actually doing. And so having something that took that RSX syntax and gave me a tree structure was really helpful just to have as a kind of baseline. So that's been fantastic work. And the author of that's been trying to get more people to adopt it over time. I know U has their own macro that they do it with. And I mean, that is a difference, right? Not everybody likes that syntax. Like, for example, Sycamore uses its own syntax. Dioxys doesn't use this syntax. U does use something like this. I think the advantage of using an RSX thing like this is you can basically paste HTML into it. So I've actually written and kind of ported portions of an app into one of these libraries that uses its own sort of domain specific language for templating. And I had to, rewrite every single thing I was porting over. I couldn't just copy and paste from JavaScript or whatever that was using, or an HTML example. So this, of course, there are some little things that have to do with, just limitations right now, like wrapping text in a string. So it's an actual string, not just plain text, that are differences from how actual HTML works. But you can pretty much paste in HTML and it will work like it should. And if you're used to front-end development, I think there's some advantage in the kind of code switching back and forth. Like if you're used to looking at a UI that's defined in HTML, to me at least, it's a lot easier to read this kind of RSX, JSX type format because it looks like a web UI. It looks like HTML to me.
Yeah, I was just trying to find what U looks like. I know that kind of is one of the biggest ones out there. Okay, yeah, I see it now, HTML. It looks pretty similar to the JSX one,
Mm-hmm.
but I don't see how you can connect a function call to clicking on something, if you can. Maybe I'm not looking at the right one. Yeah, and I know that they're much more into hooks recently. I think they're kind of also following what React is doing, right?
Yeah, and I actually think I totally understand that. So I've been noodling
Mm.
around with different Rust front-end UI stuff for, I would say, like a year and a half. I went through a sort of functional reactive programming phase, which is kind of a different variant of reactive programming. I went through a phase of trying to do stuff using actual async streams in Rust because that felt rusty to be using a native thing like that. But that had some real limitations for building UI. I went through a phase of building web components with my own little virtual DOM library that was very Elm-like, like old school U, but just to see if I could do something that was focused on making super small binaries. And what I found with that, right, there are big advantages to that state update function, view function structure, because it forces you to be super explicit and you get that Elm advantage of like, I have a finite state machine here. I'm describing a model. I have these certain messages that I can send and it does these certain changes. And it's really explicit and it creates really, I think, clean code. It's pretty verbose. Like you have to define a lot of stuff. You have to define your message type separately. And then every time you want to like add another button to do something, you're creating a new message type. And it's a little wordy. And I think that's why people like that sort of hook style. I can put my state inline in the function component. It just runs. But you lose some of that. And this is true in Leptos too, right? Honestly, you lose some of the big picture of what is the actual state of my application once you make things more fine-grained. Hooks are really interesting, right? Because hooks are almost a way of making your state updates fine-grained, but it's still feeding into this virtual DOM that's not. So I don't know what the best of both worlds or the worst of both worlds in different senses. It's kind of the best of both worlds in a developer experience sense, and it not as great for performance. But there's a lot to be said for that, to be able to make your variables smaller and just have them declared more like a normal variable and to be able to change them in a way that's more like setting a normal variable. So I understand the appeal of that, but there's something I miss about that old school U Elm type model.
Yeah, so you also have a feature called server-side rendering, looks like. Okay. You can
Oh
turn
yeah.
it on. Interesting.
Yeah, so basically the idea with server-side rendering, right, is the kind of trajectory of web development, right, 20 plus years ago, there was no such thing as server-side rendering because that's all that the web was you had a program running on a server somewhere that was serving you HTML. And then as people started adding in more JavaScript for interactivity on the front end, there's more and more of a desire to, it's hard to maintain if you just have a bunch of separate small little JavaScript functions that are updating stuff in your UI in a kind of imperative way. It's hard to keep those in sync and it's hard to maintain that. So people sort of move toward these like single page apps in JavaScript where the whole thing was being rendered in the browser and you're literally shipping like an empty body tag in your HTML and then JavaScript is rendering your whole UI. But that's, not great for like search engine optimization, is not great on slower networks and on lower end devices because it takes time to download that JavaScript. Parsing is blocking. So you can't do anything until you've downloaded the whole JavaScript file and then parsed it and then you run it, which is kind of a difference from WebAssembly, which can do this like streaming compilation. So then people have moved back into server-side rendering where I have the app, right? You request a URL from the server. I render it on the server as HTML. I send it down as HTML, and then I'm able to hydrate it on the client. So like add the interactivity and add the event handlers and do all that stuff on the client side. And while that work is happening, you see the page in front of you. So it looks like it loads faster. And if you have a device that doesn't support JavaScript or whatever, you see something. But then you get into all these problems. And this has like been the last few years of JavaScript is how do we make that faster? Because then the problem is if I'm showing you a button, but I haven't hydrated the button yet, right? So like I haven't actually added the event listener yet, and you're clicking the button and nothing's happening. That may actually be a worse experience than if you were just waiting on a blank screen. So it's, it's sort of trying to figure these things out. And pretty much every JavaScript framework now has this, you can render on the server and then you can hide in the browser. Several of the Rust ones do. Again, like U is kind of working on shipping this. Right now, U is doing only rendering in the browser. So it's doing that kind of single page app model of sending down a blank HTML page and then waiting for the WebAssembly to load and then rendering. But it's hard. I mean, that's kind of the next, like the frontier, like the next, where are we going next? What I've been working on recently is, I mean, I call them server functions, but it's basically a kind of RPC where, you can be writing your application, and rather than, 3 or 4 years ago, writing a web app, I would have said, okay, I'm going to make a REST API and I'm going to have a server that serves my data at certain endpoints. And then I'm going to have a front end app that goes and calls to those. And like, that's great. But if you're someone like me and you have a small team or it's just you don't need to triple your work by having like the server serves the data, there's an API endpoint, and then there's the client fetches the data. So what I was working on was you can write your whole thing in basically one file or wherever you want. You can locate the server work and the client work together, but there are certain things you can only run on the server. So like if I'm using SQLX or I'm using Diesel and I'm going to hit the database, or if I'm making a request to an API that I can only do from the server because I need a secret key or whatever, I need to call out to the server. But you can actually put a little async function and mark it with an attribute macro, the server. And then what that will do is in the server version, it just runs the function when you call it. In the client version, it actually makes a request to the server and returns the value that the function returns. So like, because it's an async function, right? On the server, it just calls the function. On the client, you can call it as if you were just calling the function, but it actually runs the function on the server and returns it to the client. And then you can do all sorts of fun stuff like that because you can build forms out of it. And then those forms can work even if, your WebAssembly hasn't loaded yet. So it's like a progressive enhancement and graceful degradation thing. But that's sort of one of the big areas is how do you get closer to that kind of isomorphic app? Meaning you don't have to think about, okay, do I have to move into another crate, into another file, into another like mindset to be doing stuff on the server? Or can I just write it as application code and I can tell it, hey, this should only run on the server? And on the initial render, so the whole reactive system Leptos is built on is all synchronous. So we have something called create resource that is how you kind of pull in async code, which makes sense, right? Because if you have an async function and it's to look at it as a synchronous reactive signal, it's just like an option type. So either it's resolved or it hasn't. But this allows you to do really cool things because what you can do is say I need to fetch some data from another API, or say I need to get something from the database. If you're rendering on the server, it can actually see, okay, there's a create resource in here. I'm making an async call here. On the server, it starts to hit the database while it's streaming down HTML to the browser. It keeps that HTML stream open until that data has resolved on the server, and then it streams it down and it tells Leptos, now I have a value for you. And you save a ton of time because rather than waiting, traditionally, right, you would send down this HTML file. It would say, okay, I need to load this JavaScript, this WebAssembly. It goes back to the server, it gets the JavaScript and WebAssembly, pulls them down. Then the WebAssembly compiles and loads, and it says, okay, I need to go and make this API call, and calls the server. Instead of those 3 back and forth calls, if you're server-side rendering and you can do this streaming of data, you can actually start that API call on the server at the initial call. And when it's resolved, it sends it down. So like those are the things, like the rendering speed is cool, right? Like it's nice to have the fastest framework, but these are the things that actually make a big difference in user experience and how fast your data on your website is actually loading is those bigger architectural things. And so a lot of stuff is moving back toward the server. And again, like Rust is where the server has a huge advantage over something like JavaScript.
Yeah. Okay. That's never thought about something like that. It's interesting.
And the same thing goes for, we can actually stream the HTML too. So we have something like a suspense element, if you've ever seen that in something like React. So if you read a resource under a suspense element, it's like a suspense component. It registers with that suspense component. So if you're rendering that on the server, it knows like, oh, I've got 3 pending async requests. So I'm going to hold off on rendering anything, or I'm going to render a fallback, and it sends that down. And then on the server, when those 3 requests have resolved, it will send down, it will re-render that suspense component, and it will send down the HTML, and it will actually swap it out in the browser. And what I have found, just due to the realities of WebAssembly bundle size and how fast servers are and different things, it's often the case that like the new HTML will already be there, sent down from the server before the WASM bundle has even finished compiling and started running. So it's like you are able to get just these huge performance advantages by linking together the server and the client and using some of these techniques like streaming that have been around forever. Like you've always been able to stream HTML, but people are just now kind of unlocking some of the ways to make websites really fast with that.
I mean, I'm thinking that there's people just don't think about that because you just kind of get used to your own method and what everybody else is kind of doing. There is a lot of breakthroughs coming out. In general, actually, what I was thinking earlier when you were talking, some things you need to also think about, and I'm guessing that you probably handle this, right? So, am I able to easily, say, build a binary that both has the server, can send over the SSR, can send over the templates, and do something like that? And also, if I decide to in the future, actually be able to say, okay, when I build this, give me the front end assets and give me the back end, and I want to split it off because I want to put my stuff into a CDN. Is it easy to do something like this?
Yeah, so there are some build tool limitations right now that make things a little cumbersome, and you could automate it or not, but basically the typical setup right now would be, I'll have a directory with 3 packages in it, and it's, one of them is like cargo init for the server, right? Because you're building binary. And then the client side, with the way that WASM pack works right now, is you make a library crate and you export something. And those are both basically stubs. Like the goal is for you to pretty much be able to pull in, the client folder file should be like 6 lines of code, but it just needs to exist as a separate package so that Cargo will build it for the WebAssembly version. And it may be possible to reduce this, but then you have a third folder that's your app folder, basically, where all your actual code lives. And the whole application is right there, and both the server and the client depend on that. But yeah, I mean, then you could take exactly. So you have the JavaScript, the WebAssembly. You can put them in a CDN somewhere. And to be clear, like Leptos supports the kind of pure browser client side rendering where you just write it. It just renders in the browser. You've stuck those files on a CDN or something, and it serves them like anything else. You don't have to be running a server to use it. Using it on the server too unlocks some benefits, but it's also clear like this is an ongoing, a constant debate in the JavaScript world, the web dev world more generally. Like there's a real difference between, like Ryan Carniato, the creator of Solid.js, worked at eBay for 4 years. There's a very big difference between what eBay needs and what Facebook needs. If you have a site where everything is behind a login, like it really doesn't matter how quick your initial page load is. Somebody is going to have to log in. I mean, it's a different thing. Like if you're working at Spotify, like your initial page load is not the thing that really matters to you. But if you're working at eBay, if you're working in e-commerce, that initial load is extremely important. That's really the only thing that matters to them. And so there are just trade-offs, right? Like if you want to just render something only in the browser, that's fine. It's going to take a little longer to show up for your user. You don't have to be running your own server. Like that's fine. One of the things I've tried to do with Leptos is to be really careful to make it so that it's possible to run in things like a Cloudflare worker. So I've not actually tried this. Somebody asked me, and I'm pretty sure it's possible. But Leptos is not a framework in the sense of like Axum. I remember you were having this conversation during the Axum episode a few weeks ago about like Rust web frameworks are this very kind of low-level server thing. Leptos is not that at all. It sits on top of Axum, Actix Web, whatever you want to use as your server. If you give it, a URL, Leptos does its own routing because it's kind of important to have the router work the same way on the client and the server, but you can run it on any server. So if you want to run it on the edge in one of these platforms, if it's a platform that supports WebAssembly, you can actually compile, the server side of the code to WebAssembly and run it in an edge server somewhere like a Cloudflare worker, I'm saying, because I'm pretty sure they use WebAssembly as a way of sandboxing binaries to let you run them. And that's really a growing thing, the sort of use of WebAssembly as a target for not to be running in the browser, but as a sandbox is really growing. And that's something that, we support. So there are lots of different deployment methods. Like Leptos is pretty unopinionated about a lot of that stuff. It's actually really unopinionated in general. Somebody asked me I call it a framework for web applications. Somebody asked me, do you have any native support? And I said, I don't know. I haven't used GTK in probably 15 years, but let me install GTK and see. And I actually, did a little simple counter and used the Leptos reactivity to drive updates to a widget in GTK, just like I would drive updates to a DOM element. And it was kind of funny. I couldn't actually get it to run on my computer because it was something about one of these like M1 Macs, and it was something about linking at the ARM64 versus the x86, whatever. So I couldn't run it, and I just pushed it and asked, can somebody test this? And they ran it, and sure enough, like it works. You can just use the Leptos reactivity to drive a native GUI because it's not tied to the browser at all. It's just some Rust, right? So that's like pretty cool. It's not the same experience. You don't have the template macro and all of that, but you can use the reactive system. It's like the renderer is built on the reactive system, but the reactive system is just these primitives that exist for reactive programming. So there's a lot of space for that. And the cool thing is a lot of these UI toolkits are all kind of built on the same like 80s, 90s object-oriented programming imperative patterns. So it's all just like calling imperative methods on widgets, but we all want to be doing it in a kind of declarative way where we can write it more like a functional program. And that's where all these frameworks come from. If you just wanted to write vanilla Rust, WASM bindgen, or vanilla JavaScript, you could. It's just a lot harder to keep your state in sync and to do things properly if it's all these imperative calls to update the UI. But all of these are basically just different ways of driving those imperative calls. So then you can apply the same thing to other imperative UI toolkits like GTK, presumably Qt, stuff like that.
Now, how difficult is it to actually interact with, say, JavaScript or TypeScript?
So a Leptos function, like a component, returns to you a WebSys element. So WebSys and WASM bindgen, I say these things because I use them all the time, but WASM bindgen is basically the interop between WebAssembly and JavaScript. So how Rust code can call out to JavaScript functions or to access the DOM. WebSys takes the browser, it's called IDL. I guess it's something probably like interface definition language, but they actually have this way of describing what all of the web APIs are, and then they use that to generate Rust. And so, yeah, it just returns to you like an element from the DOM. There's no special data structure or anything that we're giving you. And so, I mean, you can interop with anything. You can just use WASM bindgen to define a call out to JavaScript and just do that and call something in JavaScript. I was thinking this morning as I was walking down here, you could mount a U app inside a Leptos component because I think all you need to do is just pass it in a DOM element to mount itself on. Like we're just using kind of plain, that's what I mean about kind of providing primitives. It's a framework, like you can just use it as a framework and kind of go down the happy path. But if what you want to do is use some of these primitives to do other things, you can. So like the server functions I was talking about, that actually has nothing to do with Leptos, the reactive system or the renderer. You could just use those server function, like that macro. You could use that in another framework if you wanted to. There's nothing, it's just like defining these independent primitives and then using them to build up a framework so that the kind of interop is easy. I mean, the goal, right, is I want to be able to write an application where all my application code is in Rust because I would rather be writing Rust. But if I need to drop into JavaScript, I can. There are places where I use like this inline JavaScript feature in the framework because there are certain things that are faster in JavaScript or whatever to just do the whole thing instead of going back and forth, right? So you can do that. It's not a big deal.
And the big thing I worry about is like you never want to there's always a lot of the ecosystem of JavaScript is just huge. There's so many good things that you may want to use, like the select to drop down. I don't know if you really want to rebuild like a text editor that there's like Quill, etc. You probably
Yeah.
want to work with these things, right? So that's why I'm kind of curious about, how easy it is to work with them.
Yeah. And that's the awesome thing, in my opinion, about working with like the actual DOM and doing these fine-grained updates instead of using a virtual DOM. Because when you, like the way that the view macro works, it creates an HTML string, right, that is put in a template node and it clones that template node when it needs a new component, which is just a performance thing. But it also is like, it is literally the same as using JavaScript to create that element and putting it in the DOM. There is no difference. And so if you want to use something that, like you said, a text editor, right, a rich text editor in JavaScript, yeah, I mean, they usually say, okay, give me, a lot of them, it's like, I don't know, okay, create text editor and you pass in the ID of the element that you want to give it. Yeah, you can write that. You can just do that in Leptos, put an ID on an element in your component in Leptos, render it, and then call that function in JavaScript. Like that's fine because it's just working with the browser. Like there's no special sauce. The special sauce is all in how you reactively update the UI, but the UI itself is just the web platform. So anything that's built on that, the interop should be great. I mean, any particular example, there may be hiccups or whatever, but there's no blocker on that.
I like that you can use basically the core of Leptos and any kind of like, if I understand correctly, like you can use the core of Leptos in any kind of like templating language. It had to be HTML, could be XML, could be anything text based, basically, right?
Yeah, yeah. And so certainly, I mean, you could use it certainly like when you're in a browser, you could literally use that view macro to be reactively updating an XML document. I don't know why you would want to be doing that, but you could. And you can certainly, if you're not using the templating macro part of it, you can drive anything with it. So like the one limitation right now, in the past, I haven't tried this recently with Leptos. In the past, I've done work with like trying to use crates to do Cocoa, so like Mac OS GUI, and that particular crate, I guess it was running the UI in like a separate thread. So things had to be send and sync. And because the browser environment is only single threaded, it makes a lot of sense for Leptos reactivity to be all like RC refcell, not arc mutex, right? Because there's that overhead for being able to do thread safety, whatever. Using atomics, there's that overhead. So it is all single threaded, but you could certainly use adapt the same model. It should translate pretty well. But in general, most of these, like I found with the GTK example, like, yeah, you can just use it to drive stuff. It really is just a way of saying all reactive programming all Leptos is a way of saying, here's a value that might change, and here's what to do if that value changes. And that's really useful for a whole wide variety of things. It's a really, really good way to build a renderer for a UI framework, especially on the web. But yeah, you can use it for anything.
Yeah, that's really cool. Okay, well, thanks for walking me through Leptos. I really appreciate it, and even more appreciate when you have your passion coming out. It makes it more more interesting. And I'm very surprised. Like you're like, oh yeah, I'm just kind of I'm not really deep into software, but like a ton of stuff about this, and maybe it's become frustration that you just learned a lot, and then just kind of becomes second nature.
No, it's just joy. I'm just super passionate. It's just really fun, right? I mean, that's the thing, right? I just have fun with it and it's nice, right? I think one of the great things about having a hobby or having a side project or having something that's not your job is that it's all joy, right? Like you don't have to do anything for anybody else. And so I'm now finding, of course, as this has gotten a little more popular, or a little more visible, a little faster than I had anticipated. There's a little more of that like maintenance and, helping people and, Greg, why is your code so trash? And trying to just work through some of those things. But it's just fun, right? And even if someone's day job is like coding all day, I think sometimes you can have that fun, passionate side project. And that's what this is for me. My day job just isn't necessarily programming all the time, but it's super fun. And like I said, a lot of this just comes out of having been messing with this stuff for literally 20 years and seeing like the bigger picture. I think a lot of people come into web development in particular and get very caught up in what are actually very recent trends because they're coming into it, they're just learning, they haven't seen the whole story. But when you have been in the field, even in like a less involved way for a long time, you sort of see these things come and go. And like I basically missed React. Like I was getting a master's degree, I was doing different stuff. I did some Angular programming, and then Angular JS, which was the kind of original. And then I came back and was like, oh, Angular 2, this is cool. Oh, there's this thing called TypeScript, and getting back into it. And there were whole trends that I just basically missed. And I'm kind of glad that I did, right? And, that's not to say that any one library is bad or anything, but just having some of that perspective over time, I think has allowed me to kind of see where I want to go and to try a lot of different things and see what I want to do with my work.
I know for me, like I'm all JS'd out, the least amount of JavaScript I have to, and I've kind of settled on Phoenix Live View for most of my stuff. I haven't found like the winner of if I were to do something in Rust front end. This one may be you. I don't know. I have to see what kind of clicks. But right now, I just kind of sprinkle like Alpine JS on the stuff, and that just kind of gets me the rest of the way there.
Yeah.
If I really need something.
For me, actually, a huge thing that's been cool about I still do a lot of work in JavaScript is hybrid mobile apps. Like if you're like a freelance dev like me, right? The fact that I can use something like Capacitor and just wrap a web view as native app and run that whole thing offline with no server. And because people often want offline modes for things, right? and being able to give you like 3 apps for the price of one, a web app, iOS, and Android, and be doing that whole thing in JavaScript because that's what can run in the web view is awesome. We may well be already at the time where people are publishing U apps, maybe one day Leptos apps or Sycamore or whatever in the app stores as native apps because you can wrap it in a web view. So like that's the cool thing to me about these front end only approaches, or at least these web based approaches, that they really are like it is the universal platform. And especially if you need an offline mode, doing this rendering in the browser can be super powerful. If you have the kind of application where you can ship a lot of your data as JSON files that can be stored on that device, that's really powerful. I mean, most applications still need some kind of server API for what they're doing. So that's, you could be running the whole thing and you could be running Phoenix Live View in a native app, right? It's really powerful. I think it's a really exciting development in general. We're just unlocking the ability to like use all these different technologies together to make stuff for people.
Now, have you ever taken a look at Flutter before?
I have taken a look at Flutter. I have it makes me a little nauseous, right? My Flutter is a great example to me, what I described as that first kind of very naive view of how to solve the problem of writing web UIs in whatever language you want, because Flutter ships its own renderer. At least the last time I looked into it, this was true. Flutter ships its own GUI renderer and renders in a canvas. So you lose all of that interoperability with a JavaScript text editor or all of the accessibility. I mean, you see people in the Rust UI world like struggling to implement good accessibility, like tabbing into an input, right, is like genuinely a hard problem. And browsers, they've been working on this stuff for 30 years now. Like they do a really good job of a lot of that basic accessibility stuff. And I just don't know what the story is on that with Flutter, but I'm kind of suspicious. And it also, like the biggest downside of WebAssembly right now is the binary sizes that you're shipping down and the load times on that. And we're not there yet. And I just worry about a pattern where we're shipping more stuff and waiting on more stuff so we can do this kind of custom rendering. But this may be like my opinion without having looked into Flutter that much, especially recently. So I may be wrong.
No. When they first came out with the web part, again, they didn't have it. Now they have some accessibility. They have the tabbing. They have this kind of stuff. But what I'm more thinking about is like that you're talking about how you can ship stuff and saying, okay, this is your web, this is your local, or whatever. For Flutter, you can get native apps very easily, and those are already pretty good. I think the accessibility support on native apps is pretty good. Web,
Yeah.
it's still coming along, but I think still to get that. That's why I was kind of curious what you thought about that.
No, I'm definitely in the divide between like people who like Flutter and people who like something like Capacitor, which is there are these different approaches like Capacitor. Tori is getting, I think, is really cool. Electron or something, right? Where you're wrapping a web view, and wrapping a web view lets you ship to every platform versus like shipping a custom renderer for every platform. I'm very much in the wrap a web view camp. I mean, I've seen it benefit me. And so being able to reuse stuff across applications that, or being able to just pull in a JavaScript library to do something, that's like really helpful. It's been great in my own work. But I also like, there is a little bit of the purist in me, right? Of like, you can hear it in some of that passion about like the VDOM versus fine-grained reactivity, right? Like, why would I do all this extra work if I could just use what's already in the platform? And like the stuff I'm working on now of like doing RPC using actual HTML form elements, right? It's like, why would I rebuild something that's already there and is really good? And honestly, people who are much better, much more experienced programmers than I have spent decades of their lives working on. So like, I'm just going to trust that the web platform and the browser works, which is, not always the best thing to trust, right? But yeah, that's just kind of my take on that.
No, that's a good point. Yeah, I see what you're saying. But I think that for the web part, I think you have a lot there. For the native part, yes, accessibility is something huge, but it's something that I think that most people like me don't ever think about because we don't have to usually make apps for people who need the accessibility. And don't get me wrong, it's important, but it's just never like it's like security. It's not like the first thing off the top of your head when you start making an app.
Totally.
You never think about this kind of stuff. For me, I think about all the things that why is it that my app on iOS acts like this, but then on my Android acts like that? That to me is a big problem. And like, how can you solve this with the current technology? And I don't know about you, but I played with Ionic before. I really hated it. I hate looking at Ionic apps because you can see it's HTML and you can feel the experience is not good, right?
Yeah, I'm laughing because I like ship multiple, like Ionic has paid my bills, right? But yeah, no, I totally hear that. And there is that cookie cutterness of it too, right? I think it depends a lot on the app too. I have found exactly what you're saying with Android in particular. I often have people coming to me with bugs of like, this doesn't work on my phone. And I was like, oh, well, I don't know what to say. Like, I don't have your phone. When I test this on Android, it's fine. I don't know why Android is behaving differently on your phone than on my phone. Like a lot of those differences, just it's hard when you're trying to target product that like billions of people use right in the world and have it behave the same way on all of them. But yeah, I mean, I think Capacitor, Ionic, they've done a good job of doing cross-platform wrappers for some APIs. You don't have it for everything. So like I've definitely had to drop down into Swift and Kotlin and try to mess my way through these languages I do not really know and don't enjoy using, Xcode and whatever in Android Studio to build plugins and stuff on occasion. Would not recommend that experience. So there is some advantage to the, it's I guess the same with Flutter though and Dart. Like if somebody else has provided you the API to use the platform feature that you need, then you can use it. If not, you can't. And I honestly think it's actually a bigger problem. One of the big problems is that the web views, Apple and Google limit the web views to not include all of the web APIs that they support in an actual browser. And they limit their mobile browsers to not support all of the APIs that a regular browser supports. And Apple in particular, like they claim that this is the name of security, whatever. It's in the name of pushing people into their own ecosystem. So if they actually supported the full range of web APIs that they do in a regular browser, I think a lot of that experience would be really different using those kinds of hybrid apps, because things like notifications, even push notifications, or things like the media session API, which lets a website sort of use your play and pause keys and all of that stuff. They don't support in their mobile web views, but they could. So it's like they're giving you this sandbox that's limited in its features so that you're pushed into their own particular competing ecosystems. I mean, that whole thing is, if there's one thing I want to give up, like JavaScript, I would love to be able to give up JavaScript, but I would really love to be able to give up the App Store processes and going through all of that. It's just such a pain and such a drain. And that's the great thing about building stuff for the web, right? Is like you have a URL, that's you. Anyone can go to it.
Yeah, I know what you mean. I've been doing web for a long time, and Android's a little bit more open, I think,
Yeah.
compared to Apple. So, like you said, and it's just like, well, shit, I don't really want to do a PWA, and because like Apple doesn't support it, and that's already like half my users at least.
Yeah, exactly. You're going to charge 30% of any transaction.
Google does the same thing.
I
So,
know, I know, I know, I know. No, I think they've really converged in a lot of ways on some of those policies. Like I've even seen
yeah.
changes in the last few years in Play Store policies to become more restrictive in the same ways that some of the Apple policies are, because I mean, that's their competition, right? So why would they not be equally restrictive to their own benefit? But I
Mhm.
will say, right, I do think one thing that is a cool use, right? Some of these Rust UI toolkits, and this is kind of going back to that like Flutter conversation. Some of the Rust UI toolkits have demos of doing where they are implementing their own native rendering. They'll then ship demos for the web and show you like this thing also works in a canvas. I think that's kind of cool. I mean, those are clearly primarily intended for the native platform. And it's like, okay, if as a side benefit, it can also render something to the web, that's cool. Or it's at least fun just to see what their UI looks like on your phone or whatever. But I do worry about like doing that as your approach to the web in particular, right? Especially if you're, a project the size of Flutter. Like I think the web is too good to be replaced. Like HTML is annoying in some ways, JavaScript is super annoying in some ways, but like the actual web platform is really, really good. And I think replacing it is not the way forward.
Well, the weird part about HTML is like basically the very first web page out there still has to work in your browser,
Hmm.
as far as I understand. So it's just insane, like all of the backwards compatibility built into the web. It's nuts. Like the stuff that your web browser does for quote unquote bad developers or initial HTML is really crazy. There's a video about this like on Computer File, I think. Yeah, it's your browser is extremely forgiving, and nobody
Yeah.
has any idea.
And the browser is extremely forgiving. Like, and this is what actually opens up some of this really cool stuff with like the HTML streaming that I was talking about, right? Because if you send an invalid HTML document, like it's got an open HTML, it's got all your head, it's got the first 2/3 of a body, and then it just never closes the body tag, that's like not valid HTML. If this was an XML format, that's not valid XML. It doesn't have the close tags at the end. But the browser's like, yeah, fine. I'm just going to render what I have. You've sent me like a broken web page, I'll render it. And that means you can keep the body tag open. You can be doing work on the server. You can be sending stuff down through that same stream. And that's without doing anything like WebSockets, like server sent events. Like there are ways of doing those kind of long running connections, But this is just like keeping your HTML file open. And I'm talking like, I tend to use Actix Web for the Rust backend stuff. I can literally just return a stream or like a Rust async stream of strings, and it just sends down these chunks of HTML. Like that's really powerful. I don't think people understand how powerful it is unless you're doing this kind of stuff where you're trying to render things. But that's amazing. Like that's really cool that your browser will let you just send a bad HTML file and then you can just keep putting more stuff into it. And that's actually, if you go to Google, right, they actually do that. Google uses in-order streaming like that. So if you do a Google search, it will show you the top part of the page and then it streams down the rest of it. That's not like a JavaScript effect. I'm pretty sure that's actually streaming from the server. They use that to show you something as fast as they can and then give you the rest as soon as it's there. And that's just how HTML has always worked. And browsers just have to know how to parse that stuff and be really forgiving. And it unlocks really cool things.
I didn't even know about Google, but it makes sense. I do remember hearing about this from Ruby Rails community like a long time ago about like HTML, like not actually enter your page. And they were talking about that you would just be like forever loading in stuff for like forever. What do you call
Yeah.
it? Like,
Infinite scrolling.
yeah, infinite scrolling. That was what
Yeah.
they
Yeah.
were talking about, I think.
Yeah, that's hilarious. Yeah, I mean, it's really funny. It's HTML streaming it's becoming big in the JavaScript world right now, but it's really funny. I would have to look up the actual details, but you can find articles from like 2004 that it's like HTML streaming, the forgotten technology. And now in 2022, we're rediscovering it again and how powerful it is because it's amazing. The web is amazing. And so much of that, right? It's funny, like there are it's a relatively young technology, right? It's like 30-ish years old. But there are so few people who have the way tech works. There are so few people who have like been, individual contributors writing code for the last 30 years who like remember the ancient, techniques they used to use. And now some of the stuff is coming back. So I don't know. It's pretty funny to see the old made new again. Like people are joking about, we rendered everything on the server. Then we moved it all to the client because the server was slow. And then we realized the client was slow. So now we're moving it all back to the server. But we've made the server faster. We're no longer sad about PHP has gotten a lot better in that time, right? So it is this kind of constant cycle. And we'll see where it settles out. I think there's a lot of change coming in the next few years in the web.
Yeah, I guess it's going to be some kind of, I think it's going to probably stay in the server eventually, or maybe it just keeps flip flopping, or maybe some kind of half thing. I don't know. Who knows?
Yeah.
Well, I appreciate the time that you've given us. You give us kind of more than what we allotted, but that's fine as long as you're not, let's not make you late for anything. That's important.
That's because I just talk 50% more than the average human being. So
No, I appreciate it.
I've been
It's all
really,
interesting
really,
stuff.
really happy to talk through things with you. And it's been fun.
I appreciate you sharing all about Leptos. So maybe keep in touch and see when Leptos is kind of 1.0 and when we should really be checking it all out.
Yeah,
So
yeah,
it looks like
absolutely.
008 was what I saw on the benchmark, right? Is that
Yeah, yeah. I
September?
think 008 is in the benchmark. I think I just published 0012 last night. I'm trying to stay pretty, I'll say in the month since I basically made the repo public, there have been one or two like breaking changes in the APIs of the kind of core reactive system and stuff. And those have both been making something less restrictive, like removing a clone trait bound or removing a serializable trait bound. And sometimes then it's like, oh, well, instead of giving you an owned thing that we were cloning, we're going to give you a reference. But it's really small changes. I think basically the APIs are pretty much correct because this is not the first reactive library. Like I think the primitives are basically right. So I don't know. I mean, I think I'll release 0.1 when it feels like things are in a reasonable enough state and I've got the docs set. I mean, that's kind of, updating documentation, maybe putting together a website with a little tutorial and kind of explaining some of this stuff. And then, 0.1. But I honestly don't know how much will this change after 0.1 is kind of to be determined because I think that there is a lot that's up in the air still in the ecosystem. Like the things that would really benefit us are things like better bundle splitting for WASM binaries, which is a similar problem to like, why can't I do dynamic linking with my Rust libraries and that kind of stuff. They're like ecosystem things like that are kind of above my pay grade and abilities that I'd be curious about. But honestly, like once we're at 0.1, I think it's in pretty good shape. I don't know when I'll get to 1.0, but I have this very conservative semantic versioning approach, I think.
So is this actually production ready? Can we actually start using some of this in production, do you think?
I mean, I wouldn't recommend it. I think I'm not ready to say it's production ready and then have people mad at me if it's broken. There were some, bugs and stuff early on. I don't see a lot causing issues, but I would say the bigger thing, right, is I'm still trying to figure out what are the best kind of utility functions to provide and in helping people set up that server to client flow. Like there's still a little bit of awkwardness in the actual server files that are, interfacing with Actix or Warp or Axum or whatever. And I kind of want to work out some of the details of making that easier for people so that the server file can get down to be like 6 lines, just like the client file is like 6 lines, and then everything's in your app code. And there are a few things that it really is still like, I'm using this to develop my own application and I have to sort of figure out what are actually the right patterns for us. But again, like so much of this is inspired by conversations in the JavaScript world and by Solid.js that I think a lot of the really core patterns are basically right. So, I mean, I wouldn't say it's production ready because I'm not ready to make that, put people in that position. But there are definitely people who are starting to build some stuff. And we have a Discord that has been great for just people asking questions and helping me figure out how to explain things. So it's like side project ready, I would say.
Okay. Is there anything? Well, I guess you probably want people to come check out Leptos and see what they think. And is there anything else that you wanted to say?
No, that's great. I would say check out Leptos. If there are things you don't like about Leptos, check out Sycamore, which is an awesome library and one of my inspirations for sure. Similar, we have some differences in different ways, but check out Leptos, check out Sycamore. If you don't like that, check out you. Just like, I just want to give people the permission. Don't feel like Rust isn't suitable for the front end because it really is. We're at a point where it really is. And I'll say there's some really cool work being done by the Dioxys team actually on faster WebAssembly to JavaScript interop. So Dioxys in its current release is pretty slow in terms of rendering performance, but from everything I've heard from them, they're doing some really, really cool work. So keep an eye on Dioxys too, because I think it's a good time for Rust on the web.
Okay. Well, thank you for sharing all you can all about Leptos. I learned a lot, and you also helped me to remember stuff from, like you said, 2000s or maybe even before that. I don't remember how old that
Yeah.
HTTP streaming thing is. And now I'm starting to look at, is that still around? And how can I use that? Can I actually use that? It's still coming to me right now.
Yeah. Yeah. Well, good. Good. Thank you so much for the time and thanks for having me.